Okay, hi everybody, I'm Dave Aronson, and I'm here to give you a taste of ACRUMEN, which is something I've come up with to describe the key aspects that I think cover the whole concept of software quality. And you may be wondering, who is this schmo standing up here talking at you? Why should you listen to him? I am a developer, just like I presume most of you, if not all, with over 30 years of experience in a wide variety of languages, frameworks, systems, techniques, domains, blah, blah, blah. These days, I am the T-Rex, yes, that's my real job title, of Codosaurus LLC, my little one-man consultancy, which explains how I can get such a cool title. I'm also a member of the TopTal network of senior developers, designers, and finance people, and recently was admitted to their speaker network. Feel free to ask me about them. They gave me a lot of help prepping this talk, but I'm not speaking on their behalf. I'm the only one to blame for these crazy ideas, despite TopTal. There we go. I'm also the guy who suggested the current name for this group, which used to be the Polyglot Programming Meetup. But enough about me. What is ACRUMEN? It was originally a Latin word meaning sour fruit, like the lemons that life hands you by the bushelful, often in the form of low-quality software. So I'm taking those lemons and making lemonade in the form of this presentation. But what is it in this context? It's an acronym, try saying ACRUMEN acronym 10 times fast, that takes those aspects I mentioned and puts them in priority order. But unlike a lot of other attempts to define software quality, it's taking into account not only the developer point of view, but also other stakeholders like the people who are going to be using your software, the people who are going to be paying for it, or not necessarily the same, and others such as your boss. So what does it actually stand for? Long story short, your software should be appropriate, correct, robust, usable, maintainable, and efficient, meaning that first and foremost, it should be doing the right job, that being what the stakeholders need it to do. Then when we've identified that, it should be doing that right. Then it needs to be hard to make it misbehave, but easy to use and change. I know those are rather vague and fuzzy, but I'm going to wrap some definitions around those. And lastly, dead last, despite what a pedestal we developers tend to put it on, it should be efficient, make good use of resources. Now you may be wondering, okay, there's ACRUMEN, what's N? What's the N stand for? Nothing, I just typed it on to make a word. Now that we've had the overview, let's dive into the details. To get some idea how important appropriateness is, let's try a little thought experiment. You commission me to write for you a checkers playing program, and I deliver the world's greatest chess playing program. It's as correct, robust, usable, maintainable, and efficient as anyone could ever possibly want. But are you happy with it? Probably not. Yes, I see Brock shaking his head there. Why not? Because it's not what you asked for. Or in these terms, it's not appropriate. This leads me to believe that not only is appropriateness more important than any one of the other aspects, but it's more important than all of the rest of them put together. And yet, we developers are generally not taught. Not in school, usually not even on the job, certainly not in boot camps, certainly not in self-teaching, that this is even a thing, let alone a thing that we need to be thinking about. So now that we've got some idea what it is and how important it is, how do we achieve it? Ideally, you bring in the experts. And in particular, that's requirements analysts. However, on this planet, we usually don't have that luxury, unless you're working for some big government contractor or something. So instead, we have to use the primary tool of the requirements analysts, which is to go talk to the stakeholders. Yes, shock. Face to face, if you can imagine such a thing, or at least as close to it as you can possibly get. ask what they want. Keep breaking it down, ask what things mean, and ask why they want a particular thing. Not in a confrontational term, but what business value does that bring to the table? That helps you get a handle on what they need as opposed to what they say they want. What they actually want is somewhere in the middle, but you generally want to give them what they actually need. Once you've got some idea of their needs, you can construct mock-ups and prototypes of what you're going to do, and once you've got something actually working, you can give demos of what you've got done. Ideally, you should do this frequently as possible. Well, okay, maybe not to the point of really annoying them, but at least every couple months or so. That gives them a chance to say, oh, that wasn't quite what we were thinking, or they're going to nitpick, oh, that blue background should be green. That saves you from going too far down the wrong rabbit hole. One other thing you can do is propose tests. And this is where the given when then format really, really shines. You can propose them in the format given these preconditions. When this happens, usually some form of user input, then these are the results, usually something that the user sees. That makes a great bridge between the worlds of business and technology, because the business people can understand that, and the technology people can turn it into an actual runnable test. It brings us to correctness. Like the thermos that keeps hot stuff hot and cold stuff cold, how do we know when we've done the right thing? As you may have guessed, it's proven by tests. Ideally, automated tests, which are much faster and cheaper and more reliable and less error-prone than having some poor bored schlub sit there going through a checklist of actions. You can start, of course, with those high-level tests that the stakeholders just approved. So when you were confirming the appropriateness. Now, that doesn't mean you're off the hook for the low-level tests. Things can go wrong there too. So test that as well. There's other things that you can do to make your tests better. There's all kinds of advice on exactly what to test, when to write your tests. Test first versus test after, test pivot and so forth, test techniques and so on. You can read up on that later. And that brings us to robustness. Now, originally I had security separated out as another aspect, but there were a number of problems with that. First and foremost, it was nearly impossible to come up with a good pronounceable acronym. But also, when trying to distinguish between regular, ordinary robustness and security, the difference was mostly accidental versus on purpose. So I'm going to cheat a little and define them sort of together and swipe a major concept from information security, the CIA triad. Now, it's nothing to do with spies and gangsters. It's this triangle here of confidentiality, integrity, and availability. This gives us a great framework to think about just how the program should behave. If we define behaving like that, then to misbehave is to reveal information when it shouldn't, change data when it's not supposed to, or become available when it's not supposed to. Now, it doesn't have to be totally dead. It can just be mostly dead, as Miracle Max would say. It could be that the process is frozen, the network cable has been cut, whatever. And some folks would also say that it's a problem if it becomes available when it's not supposed to, but so long as it doesn't violate the other two, either of the other two, then it's not really that big of a deal. And it should, I adhere to these behaviors, even if someone's trying to force it to misbehave. So, how do we do this? Unfortunately, this is a huge topic. You could take a year-long class on this and barely scratch the surface. But as a very broad general technique, first, ask, what could go wrong? Note the tone of voice. It's not, what could go wrong? What could go wrong? I know a lot of stuff could. I'm trying to enumerate it myself. I don't need a demonstration, thank you very much. So think of things like the user could type the file name wrong. They could type correctly the name of the wrong file, or a file that doesn't even exist. The machine could run out of disk space or memory, or again, the network cable could be cut, all kinds of things. But that's mostly what could go wrong accidentally. You also have to think like an attacker and think, what are the weak points of the system? What can you make go wrong that could possibly open an opportunity? If there could be disastrous consequences to the system if it runs out of memory, can you launch additional processes and make it run out of memory? All kinds of things can go wrong. And for everything you think of, handle it. I know that's extremely vague, but the appropriate way to handle things will vary enormously. If it's just the user type the name of a file you can't open or whatever, just ask them to type another file name. On other occasions, if you think that there's a break-in in progress, data's been monkeyed with, the appropriate response may be to just shut down the entire system and not bring it back up until somebody physically goes into the data center and pushes the big red button. So you have to handle it on a pretty much case-by-case basis. And whatever kind of handling you come up with, test it. Make sure that stuff is correct. And once again, there's all kinds of other things you can read up on this. One good phrase to try to Google would be secure coding. There are many companies that give day-long and multi-day, multi-week classes in that. Next up, we have usability. It should be clear what the user can, should, and most of all must do at any given time, and how they should do it. And how they should do it should, in turn, be easy. And all this applies whether we're talking about a system of multiple programs, an individual program, or an API, whether that's binary or over REST or SOAP or Corvo or whatever. It should also be fairly clear what else the software can do for the user. And all this should be clear and easy despite various kinds of challenges the user may have. They may have little to no vision or color vision. That's one of my particular challenges. They may be low in hearing or fine motor control to use a mouse or trackpad or tap on a mobile app or whatever. They may have low literacy, at the very least in your character set. Like if I tried to use an interface in Japanese, I can speak it a little, but read it, no, not happening. They may even be of low intelligence. Yes, we all joke about stupid users, but realistically, about half of them are going to be below average. There are also some challenges that are not inherent to the user themselves. Somebody may be trying to use your mobile app on a small phone, standing up, on a bus, in rush hour mid-city traffic. Good luck with precise tapping on that. So how do we achieve usability? Again, we can bring in the experts. There are people who make their living at that, but once again, we don't usually have that luxury. So then we resort to lots and lots of lists we can find, guidelines, standards, and depending upon where you're working, doing what for whom you may even have to comply with some regulations. For instance, here in this area. I bet a lot of us are familiar with the Section 508 accessibility standards and the regulations that say you have to go by them. I just want to pick out one common guideline, which is the KISS principle, which, as most of you probably know, stands for keep it simple, stupid, or if you don't want to be so negative about it, keep it super simple. The simplicity of the typical Apple product and Google product compared to what's put out by your company, whatever that may be, probably not something as successful as Apple or Google. Now, you may have noticed me harping on testing. This is something you can test. It's not as quantifiable, not as definable, but still, you can test it. Again, there are people who make their living doing usability testing. You can bring in those experts. At the very least, you can bring in some of your target users, give them some tasks to do, and ask them how difficult they found it to do various things and what pain points they experienced. You can even watch them for various signs of frustration or helpless floundering, just randomly clicking to see, okay, what will work? I'm sure we've all been there. And if it's something you can use yourself, do so. Just remember though, if it's easy for you, that does not mean it's going to be easy for your users, because you have inside knowledge. But if you find any particular pain points, you can bet it's going to be even more painful for your users. Next up, we have maintainability, which I'm going to define as being easy to change with low fear of error. And I'll define error in a moment. And also low chance of error. Don't want to make it a dicey situation. Even for a novice developer who is new to the project. Now, what I mean by error in this case is actually two things. First, of course, implementing whatever it is you're trying to do incorrectly, or breaking something that already worked. As for the difference between the fear of error and the chance of error, I'm sure we've all been in the position of inheriting a code base that looks perfectly normal, and you dive in and it's a steaming mound of spaghetti or something. So you had low fear initially, and it went up after you dove in, and of course the chance was the same all along. Now, how do we achieve maintainability? Fortunately, the vast majority of software engineering advice is aimed squarely at this. As Sandy Metz has said a few times, a lot of the rules about object orientation are specifically about lowering the cost of future change, which is essentially maintainability. But I'm going to pick out just a few of the many, many principles you can find. First off, we have clear names. You may have heard the old joke that there are only two hard things in computer science: cache invalidation, naming things, and off by one errors. Naming things is a lot harder than it sounds at first, but it's crucially important. If you give something a vague or worse yet, a misleading name, and I'm sure we've all encountered those, then whatever poor sucker has to deal with your code next, and it may be you, long enough in the future that you've totally forgotten about it, that poor sucker is going to have to spend a lot of their mental energy figuring out and remembering what thing in the code, whether it's a file or a module or a variable or whatever, does or holds or calculates or represents what, instead of using that energy solving the problem at hand. So don't make them do that. Next up, we have single responsibility principle. A lot of you have probably heard of the solid list of principles. So this is the S out of that list. Just like a Unix command line utility, your code should, each piece of your code, whether it's a file, module, class, function, method, variable, whatever, should do one thing, and ideally do it well. And how do we know when we've achieved a single responsibility? Well, I like to tie it back to clear names. You give the thing a good clear name, and if the word "and" appears in that name, probably giving it too many responsibilities and needs to be broken up. Smaller pieces are easier to reason about anyway. And lastly, remember those tests that I mentioned in the appropriateness and correctness and robustness, and maybe to some extent usability. Those become regression tests. These address both the fear of error and the chance of error. If you're new to a project and it's got no tests, you're gonna be afraid to do much. You're gonna have high fear of error. What if you know that there is a good regression test suite that's gonna flash something red if you break something that worked? You're going to boldly forge ahead with good speed. As for chance of error, of course, the regression tests aren't going to stop incorrect implementation of what you're trying to do, but they'll catch breakage of something. And of course, you should be writing your own tests for what you're now implementing. Now, they won't stop you from writing code that's erroneous, but before it makes it into production, it's not that big a deal, and you should be having some sort of process that requires that the regression tests all pass before new code is merged in. So lastly, we have efficient use of resources. Of course, we tend to place big emphasis on efficient use of the CPU and of RAM, trade-off between those two. Bandwidth is becoming pretty important with the rise of mobile apps and other distributed systems. Disk space is now pretty cheap, but that doesn't mean you can go hog wild on it, especially with SSDs, which aren't that cheap yet. One that's been irking me lately is screen space. If the nature of your app is such that it should be perfectly presentable and usable like this big, don't demand that it be this big, thank you very much. And there are some non-technical resources that we should not use up too quickly, such as the user's brain power and attention span. So, how do we achieve it? I'm sure a lot of us have had the experience of running our program and it's slow. And you'll look at the code, oh, that piece looks rather inefficient. You spend a couple hours optimizing that, you run it again, and it's still slow. So don't do that. Measure. There are profilers that will tell you exactly where your program is using a lot of CPU time or memory or disk I/O. There are external programs like packet capture programs like Wireshark and so forth that will tell you when you're using a lot of network bandwidth. For disk space, well, you know why you're writing stuff to disk. If not, you can look at it and see. So probably use a smaller format or something. Once you've found where it's being inefficient, the fix is usually to use the right data structures and algorithms. So be familiar with the more or less standard data structures and algorithms, like know when you should choose, say, a doubly linked list versus a hash table, and when you should choose a binary search of a sorted array versus some depth first search through a self-balancing tree or whatever. Now sometimes we need to actually make more use per unit time, at least, of our technical resources, because we're trying to minimize the elapsed time of the resource. A lot of times this is solved by parallelism or concurrency. I'm not going to get into the nitpicky differences between the two, but sometimes you can go easy on things like the user's attention span. Instead of making them sit there and wait and wait and wait, stare at the screen, waiting for something to happen or to be finished, put the job in the background, give them some kind of notification when it's done. Maybe even email them the results if you have their address. And this whole thing is no silver bullet. There are conflicts between a lot of them, and you've seen a lot of overlap between them. Your priorities may be different, and all kinds of other jive, or otherwise. So just cope with it. It also does not cover things external to the software, the business value of time to market, and so forth. In conclusion, if you make your software appropriate, correct, robust, usable, maintainable, and efficient, then nobody will have cause to be sour about the fruits of your labor. Now, to keep things legal, there's the image credits. No, I don't expect you to read that. And I'd like your feedback. Does anything need further explanation? You think there should be something more or something less or rearranged in the acronym? And I'd love to work this up into longer training I can get paid for, so let me know if you want that. My contact information is there, and the slides, minus my email address, are available on the web. I have posted the bit.ly link in the discussion for this meetup. So, we have some time before the half hour I was trying to carve this down to. So, any questions? Yes, Jeff.
Is that a coding saw on the code slide?
Yes, it is. A previous version of this, I think maybe even the one that I used at RubyConf, where I gave you lightning talk version of this, said underneath, take that, Patterson. I know you saw what I did there.
Oh
no! Hearing no more questions, I will hand over the mic and the